Hi, Honors Chem. Want to talk a little bit today about these electrochemical cells. So, last video we talked about the voltage and how we calculate those type of things. Um, Today we're looking at non-standard conditions. So this is what's known as the Nernst equation, and last time we talked about your standard reduction potentials. So standard conditions have to do with the temperature, pressure, molarity of the things going on in your equation. And that's the ought, that's the zero superscript there that refers to standard conditions. If we don't have standard conditions, then we have this correction factor, okay? And I just want to explain that a little bit to find cell potential in non-standard conditions. So here's your equation. It's your E cell under standard minus 0.0592 over N. Now N is moles of electrons. It's quite often 2 because we're looking at 2 electrons being transferred to ionize these metals. And then natural log of Q. And Q is the same Q we used in equilibrium. It's a reaction quotient, and that's going to be products over reactants. So since we're looking at a solution, these are going to be concentrations, and because we're looking at solutions, it's going to be the oxidized solution over the reduced one. So the product over the reactant. Okay, so just wanted to explain this using one of the examples from your textbook. So this will be on page 935. This is example problem 1910. So in this case, they're using nickel and zinc. They're both +2 ions, so your N there becomes a 2. 2 moles of electrons being transferred. In this case, our oxidized solution will be the zinc. The zinc is in solution, so that's going to go on top. And the nickel is your reduced, and that's going to go on bottom. All right, so they work you through the example problem there. The standard cell has a value of 0.51 volts. And then you have to look at the molarities that are given to you for the correction factor. Sorry, this is log, not natural log. Okay, so they walk you through one in the example, and then the practice problem, 1910, says they're giving you a molarity of 3 molar for the zinc ions and 0.01 for the nickel. So those go into your equation there. 3.01. And this becomes your correction factor. So 0.0592 divided by 2 log of 300. And when you work that out, you get a value of 0.073. So these are the standard conditions. And then because we're not at 1 molarity, we're at 3 and 0.01, this is our correction factor. And your overall cell potential there is going to be 0.43 volts. Okay, it is still positive. We didn't change it that much, and that's how we do it using non-standard conditions.